Our next problem is a problem I really hope you guys understand. If not, come talk to me or Mrs. Morose to get clarification and additional help. So we need to draw conclusions as to what different 3D objects this rectangle came from when sliced. So we need to think about slicing. Which objects can we slice to make this 3D figure? And so one I know, which is really easy, is our cylinder. If we take our cylinder and we slice it down the center vertically, when we pull it open, we are going to see a rectangle. The other object that we could do is our pyramid. So we have been working with our pyramids, and we know since pyramids have rectangular bases, we can slice a pyramid and make a rectangle. However, we have to slice this way, horizontally. If we slice a pyramid horizontally, we will end up with a rectangle when looking down on it. The final shape that I thought of is our triangular pyramid. So, basically one of everything. Our triangular pyramid, when it is sliced horizontally in this case, sometimes it's vertically, it depends on the image and how it's laid out, we're going to see just another rectangle. If it has a rectangular base, when we slice it apart, it will have a smaller rectangle, but still a rectangle. So our three main shapes are actually the three answers for when we will see a rectangle when doing slicing. And our final question is about which container we should buy. So, you have obviously already read the problem. We need to figure out which popcorn container to buy so that we can get the best bang for our buck. So, we're going to look at each container individually. Remember, the first two have no lid. I did this wrong the first time, to be honest. And then we will be able to figure out which container we should buy. So let's see. With the cylinder, it has a height of 21 and a radius of 9 inches. So to find the surface area, I took the surface area of my bottom, which is pi times radius squared, plus the area of my square, which is 2 times my radius times pi times my height of 21. When I figured this all out, I end up with a surface area of 1,442.26 inches squared. For the volume, we know our volume formula, so we're going to take pi times my radius squared, or 9 squared, times the height of 21. When I solve, I end up with a volume of 5,343.84 cubic inches. So notice that both of these measurements are rather large. Our next shape is a triangular prism. Notice it has a height of 25 inches. The edges all the way around the triangle are 12. So we have 12, 12, and 12. And it's a height of 15 in the triangle. And that is all we need to know for surface area. So for the surface area of a triangular prism, we have, notice, no lid once more, just the bottom triangle, which is 1/2 times the base 12 times the height of 15. To that we have to add our three triangular sides, which are 12 by 25. When we solve, we end up with a surface area of 990 inches squared. We then need to look at our volume. So for volume, we know our formula is base times height divided by 2 times the length. And so our base, when looking at the triangle, 12 times 15 divided by 2 times 25. And we end up with an air volume of 2,250 cubic inches. Notice that these numbers are a little smaller than the first one. Our third shape is a pyramid. Strange storage container, but it would work. It has a square base, so each edge is 17. The height from the apex, or the point of our pyramid, is 24, and down its triangular sides, which we need to know for the surface area, is 26. So to begin with surface area, we need the area of the base, which is 17 times 17, plus the area of our 4 triangles, which is equal in this case, which is 1/2 times the base times the height of 26. When we do the math, we end up with 1,173 inches squared. Next, we have to find the volume. Remember, volume of a pyramid. Length times width times the height from the apex down, which is 24, not 26, divided by 3. When we solve this out, we get a volume of 2,312 inches, 12 cubic inches. And so, if you would look at all 3 numbers comparison side by side, we can figure out our next question. Our next question asks, which container should Quest buy to get the best bang for their buck when buying popcorn containers? And support your answer. And if you look back at all 3 surface areas and all 3 volumes, you'll see that, without a doubt, the cylinder is the one we should buy. And it's because it has the greatest surface area and the greatest volume. And so because these are the 2 qualifications we were looking at to find the best containers, that's what we want. In Quest, we love popcorn. And so we want the container with the greatest volume so we can hold the most popcorn. And so that's why we should buy this container.